A ladder 10 feet long rests against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 1 feet per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? Okay, the ladder here is 10 feet long. So I model this as this line here with 10 as its length, right? And then the distance from the wall to the bottom of the ladder is x, and then the distance from the ground to the top of the ladder is y. So I model it like this, and then let's read this. If the bottom of the ladder slides away from the wall at rate of 1 feet per second. Okay, so remember that rate is the derivative of position over time. So it's moved to the right, right? Because it is away from the wall. So we will have our dx over dt here. And the value is 1 feet per second. But then if this moves to the right, this here will move down, right? Because this is, the stair is intact, right? So it has to be falling down here. So we will have this one here is dy over dt. And then the question is, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? So the question is asking us about dy over dt when the x is equal to 6, right? Because the distance from the wall to the ladder here is 6 feet. Good. Okay, now this is a right angle triangle. We can have the Pythagorean theorem, right? So we will have x squared here and then plus y squared, and that will equal to this hypotenuse, right? So we'll have 10 squared, or let's simplify this. So we'll have x squared plus y squared is equal to 100. Okay, and we can take the derivative of both sides with respect to time. Okay, so we assume that x and y is a function of time. So we will have this one here as 2x multiplied by dx over dt by the chain rule, right? So we will have this one as the derivative of x squared with respect to t. And then plus, we will have 2y and then dy dt here, and that will equal to 100. Good. Now the question is asking us about dy over dt. So we need to isolate this. Oh, this one is not 100, but 0, right? The derivative of 100, because that is a constant, this will be 0. Okay, so we need to isolate this. So we will write it like this, 2y dy over dt here is equal to minus 2x dx over dt. We can divide both sides by 2, so both of these 2 are cancelled. Good. And now we have this one here. Okay, let's write it here. So we'll have dy over dt is equal to minus, I think we will have x divided by y here multiplied by dx over dt. Good. Now we need to find out when x is equal to 6, right? So we need to find out when x equal to 6. But then if x is equal to 6, we know the y, right? So we'll have x equal to 6. What is dy? So we need to find out this first. Okay, and we can get that by the Pythagorean theorem, right? So we'll have 6 squared, because this x is 6, and then plus y squared is equal to 10 squared, right? So we'll have 10 squared, and that means that y squared is equal to 100 minus 36, that will be 64. And so we will have y here, the positive values, because distance has to be positive, right? So we'll have y is equal to 8. So when x is equal to 6, we will have y is equal to 8, right? So now we can just plug that in when when x is equal to 6. So I have dy dx here when x equal to 6. But when x equal to 6 here, so we will have minus. This one will be 6 divided by y. Y is 8. And then dx over dt. So dx over dt is 1 here. So we have minus 6 divided by 8. That will be minus 0.75. And the unit here will be feet over second. And the minus sign meaning that it is moving down because the positive sign is upward, right? So here we will have this as 0.75. So the final answer here is equal to 0.75 feet over second with the negative sign. Okay, so sorry about that. So I will have minus sign here. And we will have this one here as our final answer. Okay, hopefully I did not make any mistakes during my calculation here. Thank you for watching, and if you get any questions, send me your problem to rdsatria11@gmail.com. Okay, thank you for watching and see you in the next video. Bye bye.